Okay, good afternoon, everyone. It is 2:30 my time, and we will go ahead and get started. Welcome to the 2026 Spring Hydrologic Outlook webinar for the Greater Mississippi River Basin. I'm Rose Freeman, one of the hydrologists here at the National Water Center, and I'll be providing an overview of the current conditions and spring flood potential for the basin. Following that, we'll hear from representatives for each of the 5 river forecast centers who will share more detailed information on their respective regions. This webinar is being recorded, and a follow-up email will be sent with key messages, a link to the story map, a PDF of this presentation, and this recording. If you have any questions during the presentation, please type them into the chat box that's found down in the bottom right of your screen, and we will address them at the end. So getting started, the key messages continues to be that the potential for spring flooding is above normal for portions of the upper Great Lakes, but remains near to below normal elsewhere across the greater Mississippi River Basin, which I will refer to as the GMRB moving forward in this presentation. And overall, there hasn't been a significant change to the conditions across the basin from what was shown in the story map 2 weeks ago. Flood risk from snowmelt remains below normal due to a lack of significant snowpack, while expansive drought and winter rainfall deficits will help offset the impact of early spring rains. I'll start with a seasonal look back at December through February. And looking here at the map, we can see that areas along the northern border, where you can see mostly white and green, stand in sharp contrast to the rest of the GMRB. This is where precipitation totals for the winter range from near to above normal. Meanwhile, the brown shading highlights widespread dryness across the rest of the basin. Most of these areas received only 25 to 75% of their normal winter precipitation. In central portions of the basin, this has contributed to a significant snow drought, while further south, it's resulted in deep-seated precipitation deficits that have left the soil unseasonably dry. Paired with that dryness was a persistently warm winter, as shown here by all this red shading on the mean temperature departures map. In the central portions of the basin, I talked about that lack of moisture leading to a snow drought. But further north, where we actually did see some precipitation, it was the record warmth that caused the biggest impacts, especially here in the northern and central high plains, where temperatures averaged more than 9 degrees above normal. This warmth prevented a deep snowpack from establishing and led to an early rapid loss of both snow and soil frost in areas that typically hold on to it much longer. Narrowing our focus to the last 30 days, we're starting to see the pattern shift as we move into spring. Here on the map, the dark green and blues that are stretching from eastern Kansas into the Ohio Valley and also parts of the upper Midwest show a significant wetting trend. This aligns with the typical climatological shift we see this time of the year, with these corridors receiving about 150 to 300% of their normal monthly rainfall. However, that moisture hasn't reached everywhere, with notable areas of dryness occurring in the middle Missouri Valley and the southern high plains, as shown by the red-orange colors here on the map, and this is where totals are still struggling to reach even half of their 30-day average. Across the basin as a whole, much of the map is still in shades of yellow, meaning we haven't yet seen the widespread rain needed to erase those winter deficits. Moving on to the current snow water equivalent, or SWE. Liquid water reserves are really only holding on in the higher elevations of the west and in the northeast portion of the basin, the pinks and purples there on the map, which includes the northern upper Great Lakes region, where lake effect snow is helping to sustain higher SWE. And when we compare that to the 21-year median, it reveals a striking snowpack deficit. While near to above normal snowpack remains in these western and northeastern areas, the water content drops off sharply, moving south from the Canadian border and falling to less than 10% of the median. In this area and further south, the basin is essentially devoid of snowpack, which is that snow drought I mentioned earlier. So the key takeaway from this is basically the lack of stored water in the seasonal snowpack. With very little snowmelt available to contribute to spring runoff, the potential for widespread snowmelt-induced flooding is significantly reduced, barring any late season snowstorms just prior to the spring warm-up in April. Now looking at the Climate Prediction Center's soil moisture ranking percentiles, we can see how all of this comes together on the ground. And really, the current soil moisture closely reflects the snowpack and precipitation patterns that we've been seeing. There are a couple of areas of interest. The soils here in the Dakotas remain wetter than normal. This is this green area right here. And this is largely due to deep frost and recent snowmelt. Moving east, soils in portions of the western Ohio Valley, right here where it's white, have recovered after recent heavy rains, which help bring moisture rankings closer to the median. 2 weeks ago, that area was showing some deficits, and we're still monitoring lingering dryness across the rest of the Ohio River Basin. The bigger story, though, is the widespread soil moisture deficits across southern portions of the GMRB, right in here. This is where soils are now in the bottom 1st to 5th percentile. With soils this dry, there's plenty of capacity to absorb any incoming runoff. Moving on to stream flows, what we are looking at here from the U.S. Geological Survey is the 28-day average stream flow compared to historical observations. And right now, stream flows are elevated for this time of the year across southeast Kansas into the Ohio Valley, which are these blue areas, this blue line right here. And this aligns with recent heavy rainfall in that region. We also see some elevated flows in parts of the upper Midwest, where early snowmelt continues to move through the system. However, there are more widespread stream flow deficits in place across portions of the lower Missouri Basin, right in here, and the lower Mississippi Basin in particular. And because we lack those typical winter rains to recharge the system, these areas in particular have a significant amount of remaining capacity to handle upcoming spring moisture. All of these conditions we just talked about are also reflected here in the current U.S. Drought Monitor, and it shows a basin of contrast, with some areas like parts of the Ohio, the Dakotas, and the upper Midwest largely drought-free, while others continue to experience moderate to extreme drought, especially across the western and southern reaches. For our purposes, this map effectively shows where the landscape has the greatest capacity to take in spring precipitation. Essentially, it's a map of our current storage capacity. And now we'll focus on the forecast over the next few weeks and months, starting with the 7-day precipitation forecast. Back-to-back systems are expected to bring widespread precipitation to the north, peaking on March 15th to 16th, with the heaviest totals focused in the upper Midwest and Great Lakes, right in here. And this is that area of 2 to 3 inches that you see. This will reinforce wet conditions, including a notable stretch of late season snow in that region. Outside of this northern storm track, the rest of the basin will see light variable precipitation through the 19th, offering little relief to the ongoing drought in the south. Now looking at week 2, using the Climate Prediction Center's 8 to 14-day precipitation outlook, probabilities are leaning towards below normal precipitation across much of the GMRB through March 25th. This suggests that the heavy northern moisture we see on the 15th and 16th will be followed by a much drier, quieter pattern. And for that same time period, the temperature outlook shows a strong signal for widespread above normal temperatures, especially for the western half of the basin. We're seeing these deep oranges and reds on the map, signifying high confidence in this warmer than average pattern. And now looking further down the road, the CPC's seasonal precipitation outlook shows that probabilities lean towards below normal precipitation from the Central Plains into the southern High Plains and above normal precipitation for the upper Great Lakes into the Ohio Valley through May. However, the signals are relatively weak and suggest a higher degree of uncertainty as we head deeper into spring. And for that same time period, the seasonal temperature outlook favors above normal temperatures across southern portions of the basin. The takeaway is that these medium to long range signals are unlikely to significantly change the spring flood outlook. Given the current antecedent conditions, dry soils, limited snowpack, and mostly normal to below normal stream flows, there simply isn't enough water in the system to drive widespread flooding. That being said, heavy rain can still cause flooding anytime, and the ultimate impact will depend on the timing and intensity of individual storms. Now let's look at how all of these conditions that we just covered are expected to impact the flood potential across the greater Mississippi Basin through the spring. And we'll use the long-range flood outlook shown here. On this first page, here we see the 50% probability of reaching flood stage. Essentially, this is our most likely scenario. Moderate flooding is possible here on the Red River of the North and portions of the Middle Mississippi Valley through here. And we see some stronger signals here in the lower Ohio Valley, where moderate to even isolated major flooding is possible. But I did want to note that this is largely being influenced by some elevated flows and ongoing flooding that is already happening in that part of the basin. Looking at the 25% probability map, we see a more aggressive or wetter case scenario. This reflects the risk if spring precipitation increases significantly, showing widespread minor to moderate flooding with some isolated pockets of major flooding possible through May. But again, this is just the worst case scenario. And now we'll get more details from each river forecast center within the GMRB. First, I'll pass it to Ryan at the Ohio Basin River Forecast Center.
All right, good afternoon, everyone. My name is Ryan Fleeman. I'm a senior hydrologist here at the Ohio River Forecast Center in Southwest Ohio. So if we go ahead to the next slide, Rose, we will take a look at, kind of a zoomed in look at the long-range outlook within the Ohio River Basin itself. This would be our 50th percentile or 50% probabilities of reaching these flood levels over the next 90 days. And we can see that much of our basin actually shows elevated levels. And I do think a lot of this data is actually a little bit skewed by basically what we're seeing right now across a portion of our area, including the Whites and Wabash River basins there in Indiana. So I do think as of right now, the highest elevations of floods are likely occurring or may even be a little bit behind us just the way we run this data. That's what we're seeing. But the 50% is what we're expecting to see across the basin. And as we do know in the Ohio Valley, we call it flood season for a reason. This extends into April and even into May. So I do think moving forward, we will continue to see the risk of both pockets of moderate flooding and generally across the basin. I think we will see more minor flooding as well. So if we go to the next, if we do the slide over, Rose, that'll give us our 25%. And this is what we deem are possible. Don't count it out 1 in 4 sort of scenario. And we see how we include much more of the basin itself. And that's just simply because of the dynamic nature of the Ohio Valley. We deal with a lot of, spring convective systems to where generally anywhere across the basin can be at risk of flooding, and it's geographically where it's situated. If we look at a lot of these, they're on our side tributaries to where, it doesn't take a ton of rain to get these elevated. What we are lacking is a lot of, consistent trends along the Ohio River itself. So overall, I think we're looking at a normal flood risk for the Ohio River Valley. I think this will center more on these side tributaries rather than the main stem itself. And it'll just be how these systems align as we move through our spring convective season. And let's go to our last slide, Rose. And this is going to take a look more at our near-term flooding. And this is generally ongoing for a lot of our areas. We can see a little bit there up in the north, the Maumee River Basin, but generally Indiana, and then down into the lower Ohio River, the Ohio River itself, down around the confluence with the LMRFC. We can just see that most of this rain's already on the ground. We're quickly transitioning our pattern to a more, zonal to northwesterly flow, which would bring a drier flow regime to the Ohio Valley. And that's just going to allow a lot of the water that is on the ground right now to drain out of our basin. And we will continue to monitor for additional flooding as we move forward. So that's really all I got for the Ohio Valley, and I'll go ahead and toss it up to the North Central River Forecast Center.
Thanks so much, Ryan. Hello, my name's Caitlin Bristol, and I'm a hydrologist at North Central River Forecast Center. If we move on to the next slide, I'll break down what we're seeing in our area. All right. Overall, we have a conditional flood risk for North Central is normal to slightly below normal. In the north, we have the Red River Basin, which has a below normal flood risk for high-end flooding due to slow snowpack, but has an above normal risk for minor and moderate due to elevated base flows ongoing. Moving down and over, rivers in Minnesota and Wisconsin have a below normal to near normal flood potential. This area is currently responding to rain and wintry precipitation, as well as drain tile openings, and that trend's expected to continue. Locations adjacent to the Great Lakes have received significant lake effect snow, as mentioned. This includes areas such as the Upper Peninsula of Michigan, Northwest Wisconsin, and the northern portion of Lower Michigan, which all have an above normal flood risk. Recently, widespread rain of 1 to 4 inches, with areas locally reaching 7 to 8 inches, raised the flood risk in Missouri and southern Illinois rivers from what we were having below normal to now near normal. This is supported by the increased USGS stream flows, as well as the drought monitor improvement. Ongoing active weather has caused some minor flooding from heavy rainfall, especially in lower Michigan. Any additional precipitation in these areas increases the spring risk, which we are watching the upcoming system ongoing. So to summarize this graphic, less than 10 locations show a 50% chance of moderate flooding, and none show a 50% chance of major flooding. Please swipe. While the 25% probabilities show a few more locations for moderate flooding and only 2 for major flooding. Generally, North Central is trending slightly below normal for higher end events that require significant snowpack throughout the season. So we're going to move on to our final slide. Here we have 3 Mississippi navigable river plots. On them, there is the conditional simulation in black, where there is a chance of exceeding levels based on our current simulations. Then there's the historical simulation in blue, which is the historical average chance. If the black line is above the blue line, it suggests a higher flood potential than normal, while if the black line is below the blue line, it suggests a lower flood potential than normal. So here we can see that the main stem Mississippi has a 10 to 20% below normal chance of exceeding moderate levels, and the Illinois River also has a below normal chance of exceeding moderate levels. Overall take-home story is that North Central outlook is below normal flood potential, but there are a few areas that need watching, such as Michigan. And I'm going to pass this presentation over to Benjamin Cipro at Missouri River Forecast Center.
All right, thank you, Caitlin. Hello, everyone. My name is Benjamin Sproul, and I'm a hydrologist here at the Missouri Basin River Forecast Center. Next slide, please, Rose. So I'll begin by saying that the flood risk across the Missouri River Basin this spring is generally below normal. Given the information that Rose shared earlier as far as the lack of precipitation, the warmer temperatures that we've seen over the majority of the basin, the minimal snowpack, especially at the higher elevations of the Intermountain West, and the dry soil conditions that have existed across the Missouri Basin this winter, looking at the next 3 months, as this first map illustrates, the long-range flood outlook at the 50% exceedance flood potential shows minor to moderate level flooding limited to the lower basin. And flooding in the lower basin is typical as thunderstorm activity drives lower basin flooding like we've seen over the last 2 weeks. In fact, the numbers here are a little bit higher than the outlook that existed 2 weeks ago. We've already experienced some tributary flooding when heavy rain fell in mid-February, and again this past week across the lower basin, which includes portions of eastern Kansas and Missouri. And these rains have saturated soils and contributed to a slight expansion of the 50% exceedance flood potential since the last outlook. If you could go ahead and swipe to the left, Rose. So as far as the 25% exceedance flood potential, this shows a much larger area. This includes many lower basin tributaries that feed into the Kansas and Missouri rivers, as well as the main stem Missouri River below Kansas City. Again, thunderstorm activity just frequently causes these areas to reach flood stage as they're pretty sensitive to any rain, especially when the soils are saturated. Other notable areas include the James River Basin, which, given its flat terrain and the potential for spring rains, is prone to flooding. Go ahead to the next slide, if you would, please, Rose. So as I stated earlier, the flood risk this spring across the Missouri River Basin is generally below normal, especially when compared to the historical likelihood of flooding. So as you see in this image here, highlighted in blue is where flood risk is below normal. And these are the rivers where the chance for flooding this year is less than the historic chance for flooding. The darker shades you see indicate further from normal risk, while areas not highlighted have a normal risk for flooding. Now, it is worth pointing out here that this map alone cannot be used to determine whether we are outlooking flooding in any given location. So make sure you go back to those 90-day outlook images that we just went over a few minutes ago. Next slide, please, Rose. Okay, our last slide here highlights water supply, as mountain snowpack is critical to water resources within the Missouri River Basin. Now, the left-hand graphic is courtesy of the Natural Resources Conservation Service, which shows snow water equivalent percent of the 30-year average. Now, on the right are the National Weather Service produced water supply forecasts similar to the Natural Resources Conservation Service, highlighting projected April through September percent of normal projected runoff volumes. Now, with the absence of significant snowfall, especially January and February, the percent of normal snow water equivalent across the Mountain West is below normal. In some cases, precipitation this season fell as rain due to the warmer temperatures and thus limited the snowpack. And so this ultimately has contributed to the below normal water supply forecasts across the Mountain West. While some locations across the Montana-Wyoming border remain near normal, as highlighted in those yellow colors, a stronger, more consistent signal towards below normal runoff currently exists across the Colorado and southern Wyoming regions, as well as the Milk River Basin, which you see there highlighted in red. So in closing, just to reiterate, flood risk this spring across the Missouri River Basin is generally below normal, and this is due to the overall drier conditions and below average precipitation. Now, minor to moderate flood potential does exist over the next 3 months, especially across the lower basin. And this is driven in part, again, by the recent rainfall, as well as the anticipated additional spring rains forthcoming. So with that, I'll thank you and conclude here for the Missouri River Basin Potential Brief. I will now pass things over to Becky Harjo at the Arkansas Red Basin River Forecast Center.
Thank you, Benjamin. This is Becky Harjo with the ABRFC, and the overall outlook for spring river flooding for ABRFC is a near normal flood risk because our climatological risk of river flooding is driven by convective rain events. And as you can see on our this slide, that we have 50% or greater chance of some minor and moderate flooding at isolated locations, especially in the Poto, Cottonwood, and Neosho River basins, and in some smaller tributaries like Cow Creek and Slate Creek in central Kansas. And as we swipe over to the 25% chance of flooding, you'll see that the risk of flooding is more spread out in multiple areas across the central and eastern parts of the ABRFC basin, especially in the eastern 2/3 of Oklahoma and in central and southeast Kansas. Our federal reservoirs in the Arkansas and Red River Basin systems respectively have 95 and 96% of their total flood control storage capacity available. So those lakes are in great condition to hold back any potential runoff this spring. Now I'll turn it over to Matt Wilson with the Lower Mississippi RFC to talk about their area.
Sorry, I was muted there. Thanks, Becky. I'm Matt Wilson from the Lower Mississippi River Forecast Center in Slidell, Louisiana. Next slide, please. Here in the Lower Mississippi Basin, flooding on the main stem river is primarily driven by inputs from the upstream basins. We are expecting those inputs to be average to below average at this time. Flooding in the rest of the basin is due primarily to heavy rainfall. We currently expect the overall flood risk to be below average for the lower Mississippi River Basin. Since the beginning of the year, the majority of our service area has received less than 75% of expected rainfall. According to the U.S. Drought Monitor, over 75% of our service area is in moderate drought or worse conditions. This all contributes to the current low flow and dry soil conditions that we see throughout our service area. With NOAA's current monthly and seasonal precipitation outlooks showing above average chances for precipitation in our upstream basins, there is still some chance of flows recovering through the spring. As you can see from this map, the 50% probabilities for flooding are very sparse and scattered, and mostly due to recent rainfall events. Please show the 25%. And from this graphic, we can see that, again, mostly sparse. We do have a few more moderates and a couple majors that pop up, and a lot of that is due to recent rainfalls. One area of concern, even though the likelihood of flooding is actually still below average, the area around the confluence of the Ohio and Mississippi rivers is of concern and can see moderate to major flooding even in below average chance years. And with that, I'm going to kick it back to Rose in Tuscaloosa. Thank you.
Thanks, Matt. We'll wrap up this presentation with a quick summary of this year's spring flood outlook. And basically right now, the story of the basin is one of available capacity. While a few areas in the upper Great Lakes show above normal flood potential, most of the greater Mississippi River Basin is expected to remain near to below normal through May. Snowpack outside of the northern Great Lakes has mostly melted, limiting runoff, and soils in the southern plains and lower Mississippi Valley in particular remain very dry. Minor to moderate river flooding is lingering in parts of the Ohio Valley, but this is a local event and not basin-wide. Looking ahead, forecasts show a split pattern, drier in the south, a little bit wetter in the north, but confidence in that is still somewhat low. And while above normal temperatures and dry soils provide a significant buffer, the overall impact of the spring season will still depend on the timing and intensity of individual rain events, which can trigger flooding even in a generally low risk year. So that covers our spring outlook for the greater Mississippi River Basin for this year. I'm going to go ahead and stop recording. And if you have any questions for any of today's presenters and haven't already submitted them in the chat, feel free to do so. And after I stop recording, we'll take those questions.